Dalton told us that atom can't be divided. That atoms can't be divided. Yes or no?
Yes.
Right. But going forward, there was scientist called J.J. Thomson. There was this scientist called J.J. Thomson. There was this scientist called Goldstein. There was this scientist called Chadwick. These scientists actually did what? These scientists actually did what? These scientists, they broke down the atom. They actually figured out that atom can be divided. Atom can be divided. And they proved Dalton wrong. You understand? They proved
Yes.
Dalton wrong. You understand? They proved Dalton wrong. Do you understand my point?
Yes.
So that means that when you are able to break down the molecule, when you're able to break down the molecule, I hope you're understanding that John Dalton told us that atoms can't be divided. Atoms are indivisible. But these three scientists, they did this tremendous job of actually breaking down the atom and finding out that what is present inside the atom. So, for example, what was the job that J.J. Thomson did? J.J. Thomson broke down the atom and he said that inside the atoms, electrons are present. Inside the atom, electrons are present. So, he discovered electrons inside the atom. Then Goldstein discovered Goldstein discovered protons inside the atom. You understand,
Yes.
right? And there was a scientist called as James Chadwick. James Chadwick. He discovered neutrons inside the atom. You understand my point? So when we are
Yes.
discussing, right? So James Chadwick actually discovered neutrons inside the atom. Are you understanding?
Yes.
Right. So these three scientists were capable of dividing the atom. You understand or not?
Yes.
So now the challenge was that okay, and we will be discussing okay how J.J. Thomson found out electrons, how Goldstein found out protons. But what exactly happened is that when these scientists they broke down the atom, so the challenge was what? The challenge was that atom is by itself very small, isn't it? Atom by itself is very small. And if atom by itself is very small, what exactly does that mean? You tell me. What exactly does that mean? If atom by itself is very small, what exactly do you think it would mean?
That it can be divided.
Exactly, atom is small. We thought that atom is so small that it can't further be divided. But these scientists they broke down the atom and they said that the atom consists of electrons, protons, and neutrons. Yes or no?
Yes.
Yes or no? So my point
Yes.
here is that when we have this J.J. Thomson this thing, so the challenge was that where inside the atoms are these particles located? Where inside the atom are these particles located? Are you understanding?
Yes.
So the very first part was so that J.J. Thomson came. J.J. Thomson came. Okay? Then Rutherford came. Okay? And then finally Niels Bohr. He came. Okay? Niels Bohr came. You understand my point?
Yes.
And when these scientists came, when these scientists came, they told us that atom is spherical, atom is like a ball, atom is spherical. Okay? And inside the atom, there is this nucleus. There is a center. And inside the center, what is lying? What is lying inside the center? The protons. So Goldstein discovered protons. But Goldstein was not aware, where inside the atom the protons shall exist. So J.J. Thomson, Rutherford, and Niels Bohr, along with their experiments, they came to the conclusion that all the protons inside remain inside a small center body. And that central body of the atom is called nucleus. And this is my atom. So inside my atom is the nucleus. Are you understanding my point? Okay.
Yes.
Inside my atom is my nucleus. Understood or not? Okay.
Understood.
That's the concept. So it says where inside the atoms are these particles located? These are located inside the nucleus. So I will say the protons are located inside the nucleus. And there, where are the electrons and the neutrons? These green neutrons. These green neutrons shall also reside inside the atom in the nucleus. So I will say neutrons and protons reside inside the nucleus together. And the electrons, they revolve around these are electrons. These dots, the blue dots, these are going to be my electrons. One, two, three, four, five, six, seven, eight. Yes or no?
Yes.
So I have what? I have my electrons right here. So these two electrons are residing inside the atom. Then these electrons are moving around the nucleus. So the blue path, on the blue path, these electrons are moving. Understood or not? Yes or no?
Yes.
So what
Yes.
is the concept? What is the concept? The concept is that the location. So John Dalton was proved wrong. John Dalton was proved wrong. Why? Because John Dalton said that atom can't be broken down. But J.J. Thomson, Goldstein, and Chadwick actually broke down the atom. And they told us that inside the atom we have an electron, we have a proton, and we have a neutron. And protons and neutrons stay inside the nucleus. You understand?
Yes.
And the electrons, they revolve around the nucleus. Are you understanding?
Yes.
They revolve around the nucleus. Okay. And also, when this electron revolves around the nucleus, so the collective name was given to them because they remain inside the nucleus together. So inside the nucleus, they remain together. So this is going to be protons and neutrons, and the collective name of protons and neutrons is called nucleons. Okay, the collective name of protons and neutrons is called nucleons. Are you understanding my point?
Yes.
Okay, so that is the concept. So the protons and neutrons collectively are called as nucleons. So I can say that nucleons stay inside the nucleus. Nucleons stay inside the nucleus. Yes or no? Right?
Yes.
Nucleons stay inside the nucleus. Understood or not?
Yes.
Okay, now understand. One second. Right. So that's the concept. It says nucleons, they stay inside the nucleus. Now, understand. Understand. Now, there is a term called as atomic number. The term called as atomic number. Atomic number means the number of protons inside the nucleus of an atom. What is atomic number? The number of protons inside the nucleus of an atom. Okay, Natalia? The number of protons inside the nucleus of an atom. Okay? That means what? That means what? That if I say the atomic number of somebody is Z, I denote atomic number by Z. Okay? I denote atomic number by Z. Yes or no?
Yes.
Right? So I'm going to say what? That hydrogen, and I'm going to arrange the elements in the increasing order of their atomic number. So if I say hydrogen and I'm writing down hydrogen at number 1, that means its atomic number is 1. And atomic number means the numbers of proton. So just because I'm writing down hydrogen at the number 1 position, that would mean the nucleus of hydrogen, the nucleus of hydrogen will have 1 proton. You understand? The nucleus of hydrogen will have 1 proton. So if I say hydrogen, helium, lithium, beryllium, you understand? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So why is that so? Because I'm writing this down at number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10. Yes or no? So if I'm writing
Yes.
down helium at number 1, hydrogen at number 1. So if I ask you to draw the atom of hydrogen, you will draw a circle, you will draw its nucleus, and you will write down 1 proton. Why 1 proton? Because the atomic number is 1. Because it is written at number 1 position. Helium is written at number 2 position. Okay? Helium is written at number 2 position. So that means what? That the atomic number of helium would be 2. Are you understanding my point? So you draw the nucleus of helium, atom of helium, and what do? You draw the circle, that is the nucleus, and you write down 2 protons. Do you understand my point?
Yes.
Okay, any doubts in this?
No.
So we have hydrogen, helium, lithium. What is lithium? What is lithium? Tell me. Lithium comes at number 3. So if I ask you to draw the atom of lithium, you will draw a circle and you will draw the nucleus and you will write down 3 protons because its atomic number is 3. And atomic number 3 means that means it has 3 protons. Yes or no? Natalia,
Yes.
right? So that is the concept. So when we are talking about the number of protons, when I'm talking about the number of protons inside the nucleus of an atom, you understand my point,
Yes.
right? So beryllium. So can you tell me how many protons will be there in the nucleus of beryllium?
4.
4. How many protons will be there in the nucleus of boron?
5.
5. Because it is coming in number 5. So what we have arranged from top to bottom, the number of protons have increased. You understand my point?
Yes.
The number of protons have increased. Okay? Any doubts in this?
No.
Right? So I am going to have, so we have to learn one series. That series is from atomic number 1. That series is from atomic number 1 to atomic number 20. And this series you have to learn. So we have hydrogen. I'm writing down just the symbols, okay? Okay, let me write in the full name. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So, if I say hydrogen is number one, helium is number two, lithium is number three, four, 5, 6, 7, 8, 9, 10, 11, 12. So, magnesium is number 12, 13, aluminum is number 13, 14, 15, 16, 17, 18, 19, and 20. Yes or no?
Yes.
So, hydrogen is number one, helium is number two, lithium is number three, and these are what the atomic numbers. And you have to understand that in an atom, the number of protons, so number of protons here would be, the number of protons would also be 1. Number of protons here would be 2. Lithium would have 3 protons. Boron, beryllium will have 4 protons. Boron will have 5 protons. You understand? And in every
Yes.
atom, whichever number of protons we have, they are also equal to the number of electrons. So if I say hydrogen has 1 proton, then hydrogen will also have 1 electron. If I say helium has 2 protons, then helium will have 2 electrons. Lithium has 3 protons, then lithium shall have 3 electrons. Beryllium has 4 protons, so beryllium has 4 electrons. Boron has 5 protons, so boron also has 5 electrons. Carbon has 6 protons, so carbon will also have 6 electrons. Nitrogen will have 7 protons, so nitrogen will have 7 electrons. Oxygen will have 8 protons, so number of electrons is equal to number of protons. That's the rule. So number of protons in an atom must be equals to the number of electrons. Yes or no? Are you understanding the logic? So 9
Yes.
protons, 9 electrons. But what is the difference? The protons, they stay inside the nucleus, and the electrons, they stay outside the nucleus. That's the difference. Neon has 10 protons, so neon also has 10 electrons. Sodium has 11 protons. Okay, so sodium shall also have what? 10, 11
11.
electrons. Yeah. Magnesium has 12 protons, so magnesium shall also have 12 electrons. If it has 13 protons, it will also have 13 electrons. If silicon has 14 protons, it will also have 14 electrons. 15 protons, then 15 electrons. 16 protons, then 16 electrons. 17 protons and 17 electrons. 18 protons and 18 electrons. 19 protons and 19 electrons. 20 protons and 20 electrons. Are you understanding my point?
Yes.
So when we have these methods, these elements, why am I calling them elements? Because if you say calcium, that would mean all the atoms of same type I have placed at one point. That's why it is calcium. And what kind of atoms? Those atoms whose nucleus consists of 20 protons. Do you understand? And 20
Yes.
electrons. So if I ask you that, how is potassium and calcium atoms different? So now you know the answer. You will say that, ma'am, if I'm talking about potassium, so potassium's atom and calcium's atom, how are they different? Ma'am, potassium's atom consists of 19 protons in the nucleus, and calcium's proton consists of 20 protons in the nucleus. Are you understanding my point?
Yes.
Yes or no? So that is the concept. So when I'm talking about sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. When I am talking about these, I hope you're understanding the logic. Yes or no, Natalia?
Yes.
Okay. That's the concept. That's the concept. Did you understand my point?
Yes.
Right? So that is the concept. So here, what do you understand from this part? You tell me. So hydrogen, helium, lithium, beryllium, boron, carbon, neon, and so on. Yes or no?
Yes.
Right? So first of all, the structure of the atom should be clear. That you know where inside the atom do we see what? Where inside the atom do we see this? Protons and electrons. And what is that number of protons? That is atomic number. Yes or no? Any doubts in this, Natalie? So if
No.
I ask you to calculate the number of electrons in an atom, would you be able to do that? Would you be able to do that? Yes. You will have to remember
Yes.
this series. Now, how do you remember this? I'll tell you the method. It's I have remembered hi, hello. Listen to BBC News of Nepal. Okay? That's how we have to remember it. How do you think we have to learn it? Hi, hello, listen to BBC News of Nepal. Hydrogen means hi, H. Hello, HE. Listen, LI. Beryllium, BE. BBC News, you know. B for boron. C for carbon. Do you know the news channel?
Yes.
Nitrogen, news N. Off. OF, off. Oxygen, fluorine. Nepal, NE. So that's how I've remembered the first 10 elements. You understand?
Yes.
So we have hi, hello, listen to BBC News of Nepal. So would you be able to remember this in order now?
Yes.
Right? Any doubt in this?
No.
Okay? So this is first 10. Next 10 I'll make you learn in the next class. But I hope you're understanding this basic concept. Tell me, Natalia.
Yes.
Right? So this is the concept. Now, understand. Now, as you move forward, okay, as you move forward, now understand every atom has some mass as well. Every atom have some mass. Okay? Every atom have some mass. Understood or not?
Yes.
You understand? So when we are talking that every atom have some mass, what exactly do you think it would mean? So you have to understand. I told you that every atom has what? What all three fundamental particles every atom has?
Mass, shape, and
No, 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 no. Every atom has three fundamental particles found in it. What three things are found inside the atom?
electrons,
Right?
protons, and neutrons.
Correct. Electrons, protons, and
Neutrons.
neutrons. Yes or no?
Yes.
So you see one thing. You tell me one thing. Let's suppose when I have a bag. So is it very heavy to lift a bag or it is very light? Tell me.
Light.
It's very light. But if I put in some apples in it, if I put in some bananas in it, then what do you think would happen? Tell me.
It would be heavy.
It would be heavy. So it would become heavy because of the things present in it. Yes or no? So if we have apples and bananas in the bag would become heavy because of what?
Because of the thing inside.
Exactly. So my point here is that if we have this bag, okay? If we have this bag, right? So what do you think we would do? Tell me. What do you think we would do? I'm saying the atom is like a bag. The atom is like a bag. Okay? And what all things are present inside the bag? The electron, the proton, and the neutron. So the mass of electron, proton, and neutron when added together will give me the mass of my atom. Yes or no?
Yes.
So my point here is the mass of an electron is going to be this, right? Any doubts in this,
No.
right? So my point here would be what? So every atom has some mass, right? And every atom has three fundamental particles inside it, which is the electron, proton, and neutron. And the mass of the electron, proton, and neutron when added together, okay? The mass of the electron, proton, and neutron when added together will give me what? Will
The
give
mass of
the mass of
the
that atom.
atom.
Yes or no? Okay.
Yes.
So if, for example, if I say there is an atom and there is this nucleus of the atom which has neutrons and protons and the electrons. You understand my point?
Yes.
So I will say the mass of this atom is equals to, if suppose it has 12 neutrons and 11 protons, the mass of the atom is equals to mass of 12 neutrons plus mass of 11 protons plus mass of 11 electrons, because as many protons, same number of electrons. So when I add all these masses, then I get the mass of one atom. Yes or no?
Yes.
You understand my point? Okay. Understood or not? Just tell me.
Yes.
Yeah. That is a concept. That is a concept. So when I'm talking about the mass of the atom, you know, that's the concept. So we have understood the number of neutron protons. We have also understood that the number of protons is equal to number of electrons always. Now we have to calculate the mass of every atom. Now there is a rule, okay? That is decided by, now you understand one thing. Let's suppose I have this bag, okay? And inside this bag, what is happening? We have pumpkins in it. We have big apples in it. We have grapes, we have guavas in it. We have bananas in it. We have watermelons in it. All big fruits. But we have also mustard seeds in it. Do you know what mustard seeds are?
Yes.
So now I have all of these things, right? I have all of these things: pumpkins, apples, bananas, guavas, etc. But the point is, when I have all of these pumpkins, apples, bananas, guavas, who do you think is actually making the mass of this bag? Tell me. Who is making the mass of this bag? Tell me.
The big fruit.
All the big fruits. And mustard seeds,
Yes.
even though they are there, mustard seeds, even though they are there, they would be so light that counting their mass would be negligible. It is not going to affect the mass of all the of the bag. Are you understanding? So my point
Yes.
is that to calculate the mass of one full bag, I would add up the masses of pumpkins, I would add the mass of all the apples, I would add the mass of all bananas, all guavas, all watermelons. But mustard seeds are so less, so small, that their mass is insignificant. Their mass is insignificant. You understand my point?
Yes.
Okay, their mass is insignificant. So my point here would be what? So my point here would be what? You tell me. When their mass here is insignificant, what exactly would that mean? You tell me. Tell me. When I have this part, right? So
Yes.
similarly, in an atom, the neutrons are heaviest. Neutrons and protons are nearly the same size, but little bit neutrons are, right. So in an atom, the protons and the neutrons are nearly of the same size? You understand?
Yes.
The protons and neutrons are nearly of the same size, and neutrons are little bit heavier, and they're approximately equal, followed by the electrons. Electrons are very light, very light. That means what? So we have neutrons and we have protons and we have electrons. Yes or no?
Yes.
That means what? That is it important to actually count the mass of the neutrons, electrons? No. So I would say that the mass of the atom is actually made by the mass of all neutrons plus mass of all protons. You understand?
Yes.
Okay? Because electrons are definitely there. If you want, you can add it up. But mass of electrons are so less that, adding their mass really does not make any difference or big change. Do you understand the point?
Yes.
So when we are talking about the neutrons and the protons, the mass of the atom is equals to the mass of all neutrons and mass of all protons. Yes or no?
Yes.
Okay, that's the concept. So now you understand a very important part here. So every atom, so now where are the protons and neutrons residing? The protons and the neutrons are residing where? Tell me. This is my
In
nucleus.
the
Inside the nucleus. And the collective name of protons and neutrons is called nucleons. Yes or no?
yes.
And nucleons reside inside the nucleus. Yes or no?
Yes.
Nucleons reside inside the nucleus. So, what is the point here? What is the point here? Tell me. The point here is the point here is when we have nucleus is residing inside the nucleus, nucleons are residing inside the nucleus. So, I would say the mass of the atom is actually made by the nucleus. Because whatever is the mass of the nucleus actually becomes the mass of the atom. Understood or not?
Yes.
Yes or no? So that's the concept. Okay? So the mass of the atom is actually the mass made by the nucleus. So rule is for every element, so I would say Z. Z is the atomic number, and that is also called as mass number. Mass number means number of protons plus neutrons together. And atomic number just means the number of protons. So every element. So if I am talking about the element, just may write on this table. So what do we have? What do we have? Tell me. So we have one atomic number, two atomic number, three atomic number, four atomic number, five atomic number, six atomic number, seven atomic number, eight atomic number, nine atomic number, 10. So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay. So the mass number is 1. For helium, it is 4. For lithium, the mass is 7. The beryllium, the mass is 9. For boron, the mass is 11. For carbon, the mass is 12. For nitrogen, the mass is 14. For oxygen, the mass is 16. For fluorine, the mass is 19. And for neon, the mass is 20. That means this table you will have to remember. Okay, I've written down this masses. This masses, I will tell you the trick as well. But these are the masses. Mass means the protons plus neutrons. And mass number is denoted with A. Do you understand my point? Mass number is denoted with A. Yes or no?
Yes.
All right. So this is the table. Understood? Or not? Similarly,
Yes.
we have elements like the other elements, right? So we have Z, the element, and A. So the table here shall be, so what do we have here? Atomic number 11. Z is atomic number, right?
Yes.
12, 13, 14, 15, 16, 17, 18, 19, and 20. So the element with atomic number 11 would be sodium, will be magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Yes or no?
Yes.
And for A, what would that be? What would that be? 23, 24, 27, 28, 31, 32, 35. Okay? 40. Argon would be 40. These are the masses. This is going to give me the mass of protons and neutrons together. P plus N together. This is going to be 39 and calcium is 40. So this table you will have to remember. Okay?
Yes.
Any doubts in this?
No.
Right? So this is the table. So we have learned today what? The atomic number and the mass number. What is mass number? Mass number is denoted with A and atomic number is denoted with Z. Atomic number is the number of protons and mass number is the number of protons plus neutrons. You understand? So this table
Yes.
you will have to remember to carry forward what is the further concepts in chemistry. So Dalton said that atom can't be divided, but the other scientists they actually broke down atom into small entities. And when they broke down the atom into small entities, what do you think it would mean? Tell me. When they broke down the atom into small entities, what do you think it would mean? Tell me. So they found out that inside the atom there is electron, proton, and neutron as well. And when inside the atom there is electron, proton, neutron, thereby they also found out that every atom has equal protons and equal electrons. Neutrons can be any, but neutrons are little heavier. Slightly lighter is the protons and lightest is the electrons. So basically, in making the mass of the atom, electrons play not a much role, big role. You understand my point?
Yes.
Okay. So that's it for today.